Um, Hi, OpenEBS weekly contributors meet, and today is 22nd of June 2018. We will have today talking about CAS templates, and basically we will be talking more about the code that has gone in to implement the CAS templates. There has been some designs with respect to design docs or design artifacts with respect to CAS templates. I can share them, and all these designs, these artifacts, are actually a work in progress. I'll share them in the chat window now. But in this session, we will be talking more about the code that has gone in to implement CAS templates. Anybody can interrupt me if they feel I'm going fast or I'm not understood at any point of time. So let me search for the docs. I can, and this is the design doc is actually a work in progress. The CAS template, again, it's a kind of a pre-alpha code. Okay, so CAS template. All right. Okay, so I'll start off with by sharing my screen. All right, I guess all of you are able to look at my screen, and we'll straight jump to the code. Okay. All right. So CAS template that we are talking about now is implemented in the repository called OpenEBS Maya. This is the repository which hosts a lot of binaries. Some of them one of them is Maya API service. We can have, this is the one. So this binary is a HTTP service. It exposes some of the HTTP APIs at one end, and at the other end, it is also a client to Kubernetes API server. All right. Okay. So, and if you go to the pull request, this is the latest PR that has been sent with respect to CAS templates. This is the PR, that is the PR 376, and at the same time I have also sent a PR which is PR 12 that is in the OpenEBS community repo. In this community PR, one will be able to find how the CAS template can be used to provision CAS volumes. Okay, so a little bit about CAS volumes, or a little bit about how the volumes are getting provisioned in Kubernetes. So Kubernetes follows the PVC PV lifecycle. That's a reconciliation loop. Whenever a PVC is claimed, or whenever a PVC is being requested, the dynamic provisioners need to provision a persistent volume. And in case of OpenEBS, it is the OpenEBS dynamic provisioner. What OpenEBS dynamic provisioner does is it makes a HTTP request to Maya API service, the one which we talked about here. This is that repo. And the HTTP, once the HTTP request is received at the Maya API service, it goes ahead and creates a couple of deployments, that is a Kubernetes deployments, and one headless service, a Kubernetes service. Once these are created, it responds back, that is the HTTP response, saying that the resources required for a persistent volume has been created, it directs that to the OpenEBS dynamic provisioner. OpenEBS dynamic provisioner in turn creates or generates the persistent volume YAML and responds to the reconciliation loop. All right, the PVC loop, the controller. This was a very high-level view of what happens in the PVC PV reconciliation or the controller in a Kubernetes. We will be talking specifically about the Maya API service part, which has the logic to create various OpenEBS related resources before responding to the provisioner saying that a PV, all the required resources required for a PV has been created successfully. Okay, and the logic to create these resources are embedded or declared in something which we call as CAS templates. CAS stands for container attached storage, and it's known as also templates because it's a templating format. It's a declarative format to declare what kind of OpenEBS resources need to be provisioned before responding to the dynamic provisioner about the PV, right? Okay, so when we talk about CAS template is a Kubernetes custom resource. We can have a look at that now. So this is currently the file which defines the custom resource, which defines CAS template as a custom resource. So this is the custom resource definition, which is shown as a Go structure. If you see, it has all the attributes that a typical Kubernetes resource has in terms of metadata, in terms of type meta and object meta. The thing that is specific to the CAS template is the spec, and which is this one. And you can see that there are some elements of update. We are not going to cover about update now. It's still under discussion. The things that we are concerned about today is the config. It's an array of config elements that can be given. There is something called as task namespace, and there are some other things called run tasks. And at the last, we have something called as output tasks, right? So what is this task all about, right? So CAS template, as we are seeing, this is a custom resource, and this kind of composes a series of tasks which is known as run tasks, right? Let us have a look at what exactly is a run task. The run task here, if you see, this is just a array of strings, which actually means it actually points to the name of the run tasks. The actual definition of run task is not present here because it is currently not a custom resource. It's a structure though, but it's not a custom resource. Let me show up some other things which will be helpful for us to explain about explain about the run tasks. I will. Okay, so let me. Let me just have a look. Okay, so what was this community? This is all right. So okay, we were searching about the CAS templates, right? So this is the YAML representation of the CAS template that we are talking about, right? So like you said, this is a custom resource, and this is the definition. If you remember the code, it talks about some configs, right, which is an array of config elements. And this is that config, and if you see, these are the array. It's an array of name and enable. Sometimes it's a name and value, whatsoever. It's an array of some configs. It's a list of some configs, and one is able to provide a config name and the config value, or if the config name is kind of a boolean, it can be given as a true or false, which in turn translates to if it is enabled or if it's disabled. If the config element is a it's a kind of a value driven, the exact value can be given here, right? I'll come back to like what exactly these are, but this is all about the CAS template, and this is the configuration elements that can be specified in a CAS template. And we scroll down, and this is where we see about the task namespace, which is known as the default, which means the tasks that are present here, the run tasks that are present in the CAS template, can be found in the default namespace, right? So in other words, the run tasks are namespace scoped. And there are a series of tasks that has been defined in the CAS template. One such is like the volume create pull service, put service, and there is something called volume create get path, and so on. And this again is a list of tasks, right? And CAS template engine, that is the code or the logic that understands the CAS template, ensures that the tasks are run in the order that is mentioned in this YAML file. If you look at this example, this is the task which will be run first, right? This one will be run first, and then the next one, and so on till the last one has been run. And all these tasks are defined as as config maps, right? In other words, these are the run tasks that has been defined as config maps. Sorry, just CAS template. Okay. If you look around here, okay, it's defined at some other place. I think it's defined here. Yeah, if you see this, that particular task, which we are calling it as a run task, has been defined as a config map. It has some elements inside it. There are three properties that defines a run task. The first one is the meta property. The next one is the post property, and there is another property which is called as a task property, right? So this is a way where in which one can define a run task, right? And like I said, CAS template will try to run or execute these run tasks in an order. If at all there is any issues while running a run task, then CAS template has inbuilt logic to roll back the previously executed tasks, right? And at the last, we see another thing called output in the CAS template. So still we are talking about the CAS template, right? And we see something called output. Again, if you try to check it in the code, this is the property we are talking about here, right? All right. So this output again points to a run task. Okay. And if we go and try to check what is that run task, that again is a config map which has been defined in a particular way, right? So we talked about CAS templates. We just saw a CAS template definition which has some configuration elements in it, which has something called a task namespace, and we uh, understood that this is the namespace where the tasks can be found. And then we also saw a couple of tasks. These tasks are config maps, right? And we also talked about output. Output also is a run task, which means it is also a config map, right? So let's talk about one such task. Well, let's talk about one such config map and try to understand what it is all about. Okay. Any questions so far? Anyone has
Amit?
any? Yeah.
Okay. Just to you were planning to show the code associated with how that run tasks were there. I think slowly we shifted into explaining about the CAS templates here. Um, can you map that? If you go back to the previous run task listing, right?
Okay.
Okay. So
Okay.
now it has a default config, I understood, and then uh, these are the list of the tasks. And can you map this into the code and show there what
Yes.
happens?
Yes. Okay. So that's a good question. So if you see, this is the CAS template specification, and within that we have a property called run tasks, which is annotated as run. That means if it comes up as a JSON payload, and in that payload there is some property called run that will refer to the run tasks, right? So this is the run, and we will immediately go to the run tasks, right? And this is a structure, and here if you see, this is an array of strings, um, right? And which is again understood as a set of tasks, right? A set of tasks is an array of strings. So here we have the tasks property mentioned, and within that in YAML, if we start with a hyphen, that implies it is a array element. It's a list of array. So with a hyphen, we start putting the values, and because each is a string, this is a string, right? So by default, it is able to understand that any alphanumeric stuff is should be a string. We need not put double quotes and all those sort of things. So these are the array of strings that gets populated in this particular property. Um, okay. Um, all right. Similarly, the output task, which is also a string, and that refers to the string that has been defined here, right? Um, okay. So what I will try to do is, okay. So Kiran, does that answer your question?
Yes, I
Okay.
think the next step would be like,
Yeah.
if you go through the flow of how this task is getting accessed,
Right.
right? And then we can check, okay, that string, uh, it, though it is just a string, it
Right.
seems to have some connotation to it, right?
Right. 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 Yeah.
There is that
Yeah.
relationship maintained.
Okay. So let me go through some of the things like task fetch. So there is something called a fetch, which is present in the pkg / task namespace. Let's get into that particular file. This particular file deals with fetching the tasks, right? That is associated, which is nothing but a config map. Um, and here are a set of interfaces, which exposes one contract, which exposes one method. Given a task name, it will fetch the entire the run task for us. Okay, so the run task has been defined. I'll just get into the run task as well. Okay. All right. So if you can see, this is one of the structures which particularly defines a run task, right? We earlier we saw a structure which that defined the CAS template. This is a structure which tries to define a run task, which is again those three properties: meta, task, and post that we talked about. uh, but we don't see any JSON stuff here. It's because we are not expecting this to be coming in a JSON format, and then setting and then getting set automatically. Um, Rather, what we are doing now is we are actually fetching them, and like we discussed, these are all config maps. We are actually fetching them as config maps. If you can see, we are invoking the client code, the Kubernetes API client um, library to get the config map by providing the task name, right, which is nothing but the config map name. And we provide some of the options, which is currently nothing. We just give the task name, and before that, whatever this particular client API, right, it has been configured with that namespace, the namespace that we talked about earlier, right? The task namespace, which is here known as a search namespace. But this is that namespace which has been already configured with, right? So we have got the Kubernetes client, which has been configured with that task namespace. And then when we are trying to fetch that particular task, which is nothing but a config map, we do it via the task name, the config map name. And once we get the config map here in this particular object, we try to extract the meta, task, and the post properties, right? And we build the run task structure. Uh, this is how a one task is getting formed, is getting fetched and formed. Now, if you see pkg, all right, what I will do is mm, I will try to now try to give some information about from the API point of view. So whenever a HTTP request comes to my API service, it will be handled in this package, which is in the CMD Maya API server app/server. That's a package, and this is where it will be intercepted. And uh, the one thing that we need to know about the CAS template is it's a feature gated. So there is a switch involved based on if the feature gate is enabled, if the CAS template feature gate is enabled, it will go to some other place. It will be redirected to some other place. If it is visible, it will continue with this endpoint, right? So these are the handlers which handles the HTTP requests. We will go to the endpoint that manages the CAS template, and we will have a look at it before getting deep into the CAS templates. So this is the one, the V1 Alpha 1 endpoint is the one which handles the CAS template. The switch redirects to this particular place, and in this particular place, we do again some case statements. If the request is a post, get, or delete. If it is a get, then within the get, it will check if it is a list or if it's a simple get of a one volume name, right? We will go to the post, that is a create part. In the create, if you see, we try to unmarshal whatever payload has been provided into something called as a CAS volume. This is one structure that is internally understood by the Maya API service and also understood by the provisioner. Both of them interact using this structure, this payload. And if you see, so these are some of these housekeeping stuff, like we check if the volume, namespace, and all those things are available or not. And once these all passes, what we do is we try to create the volume using something called some volume operation. Now let's get into that part, the volume operation part, which is present in pkg volume volume.go file. And so this is what we invoked in the handlers, right? This is the one which we invoked here. So we'll close it down and we'll come here. So here, what we see is this is a structure which again tries to get a Kubernetes client depending on the namespace. This is a namespace which is supposed to create the CAS volumes. this namespace is the one which will be available in the PVC itself. The PVC should be providing this namespace. And so we create a structure called a volume operation, which has got a method called create. So this is where the actual core of defining the CAS engine comes up. So in some of the parts, in this part, we see that it tries to capture the capacity, and if at all the capacity is not available, it will throw up an error. There are some commented code which will be uncommented once the provisioner, the OpenEBS provisioner, is able to support the CAS templates. When I say support, it needs to be requesting the endpoints in specific URLs and giving the specific payloads, right? So let's see here. So this is something that the operation, when it tries to create a volume, it tries to get the storage class name, right? Because the storage class is the one which would have registered the CAS template. And so this name is expected to be found in the volume and as a label, in one of the labels, and is expected that the PVC should set this up before sending a request to the my API service, right? And if at all it doesn't find a storage class name, it will throw out an error. From this storage class name, okay, so this is a storage class name, and this is where we try to get the storage class object along with its properties. From there, we try to so there is a concept of we saw that CAS template has got the concept of default config, right? We also extend that config. We also provide support to the same config element in storage class, right? So if at all the config is present in the storage class, that will hold more priority than the config present in the CAS template, right? So this code is about that. It tries to get the config elements if at all it is present in the storage class. And then the next thing is it tries to get the CAS template name. We, like I said earlier, we can have a look at one of the one of the storage class, right? So I'm talking of a storage class now, and I'm talking about the annotations. In the annotations, in this particular format, in this particular key value, we expect the CAS template to be provided. And here we see only the create template. There is also CAS templates for get, list, and delete, but those are considered as even if those are not provided in the storage class, and they need not be provided from the storage class, it will pick up, the My API service will pick it up based on some of the default naming conventions. Okay, so at this stage we get the CAS template name, which is about the create part. Okay. All right, and if at all it is not available, it will throw out an error. Now from the CAS template, what we see is because we try to get the CAS template object, and to get the CAS template object, we have to follow the typical Kubernetes client code. Because this is a custom resource, there are a certain amount of code generations that happen, and this particular method invocation is a result of that code generation, where we just need to provide the CAS template name, and we get that CAS template, the entire thing, right? And one thing that we need to know is the CAS template is cluster scoped. It is not namespace scoped, unlike the run tasks, which are in namespace scoped. Okay, so here comes the engine part. This is the CAS engine. We can build different kinds of CAS engine depending on the requirements, depending on the tasks that the CAS engine needs to perform. In the create, while building the CAS engine, which is meant to do a create operation, of CAS volumes. It expects some of the things like the config element from the PVC, the config element from the storage class, the CAS template object itself, and then these are some of the key value pairs. These are some of the values that it also expects. Now these values are the runtime values. Okay. In while creating a CAS volume, we expect the volume name to be present, the capacity to be present, the volume namespace to be present, and also we expect the PVC name to be present. These are for some reasons. Obviously, name, capacity, and namespace are a must. PVC name, we require it. There are some other requirements due to which we need a PVC name. We'll skip that part now. But the important thing that we need to know here is this is the engine creation part of CAS template. That is a CAS template engine, and this is specifically meant for create of CAS volume. So what we'll do is we'll get into the file which has this definition. So once we create the engine, it invokes the create method, and that is it. There is nothing much here left. The CAS engine also is present here. We can think about moving it to some other namespace because this is the volume namespace, whereas we expect the CAS template engine to be a high level abstraction, not just a volume specific stuff. So we can think about that. We talked about creating a CAS engine. We'll go to that particular operation. All right, so here we are. I'll just close off the old one. So like I said, it expects some of these elements in order to build the CAS engine, the structure, right? And if you see, it's important here that we see the structure, how the CAS engine is has different structures that helps it in building a generic CAS engine or a specific CAS engine, depending on the requirements. Okay, so these are some interfaces which exposes some of the contract methods. For example, create, delete, list, and read. And these are generic. There is no these are generic, but the comments say that it is for creating a volume and so on. But these are actually generic. So what we can do is we can remove out these comments and say like and put some generic comments instead. All right. So here, while we were trying to do the operations for CAS volume, let's say create, list, delete, and get, we could see that there were some common elements, right? There were some common operations that were common to all these get, list, and delete. So what we have done here is we have created a common structure, and it has got some of the properties, right? For example, one of the properties is how to fetch the the tasks that are specified in the CAS template, right? And there is also something, a runner object, which is all about running the tasks in a specific order. And if at all there is a error that occurs in one of the tasks, this runner's job is to roll back the already executed tasks, right? Apart from that, there is something called template values. So this is all about, so CAS template relies heavily on Go templating, and Go templating has two concepts. Okay, it has kind of two aspects to it. One aspect is a templating part, right? The other aspects is a values part. The values and the templates together, they are fed to the Go template, that executor, and it results into a final object, which will be a kind of looks similar to the template, but with the values placed at particular placeholders. That's a kind of a very simple definition of Go templates. And this is where the values comes in, right? We know that the run task itself will have the template. Till now I have not shown like some of the details. Yeah. So this is a config map, which is again a run task, and this is about putting a service, right? So if you see the task part, if you see this, right, this looks very similar to the service, right? A Kubernetes service, which is in fact a Kubernetes service with particular version, with particular kind and metadata labels and all those stuff. And if you see these curly braces, the double curly braces, these are the ones which are actually will be filled up by the values present in that template values that we talked about just now, right? So the task, if you see in the run task, there are three properties or elements. One is a meta, one is a post, and one is a task. The task itself is a kind of it's a template, and the template can be any Kubernetes resource. And in this example, it's a Kubernetes service resource. The meta part tries to give some definition about what needs to be done to the task. In this particular case, it needs to be put into the Kubernetes service. That means it needs to be applied to the Kubernetes cluster. It needs to be applied to the Kubernetes cluster. And the task is of type service. There is some amount of redundancy here, but just bear with me for that. And where it needs to be put, and this is the namespace. This is the namespace where this needs to be put. All right, and it also has a concept of ID, so that if at all the task executes successfully, and after that we want to extract some of its values. In this particular case, we definitely want to get the cluster IP, right? In that case, it is good, to have to mention an ID for this particular task, and store the required values, for example, cluster IP in that ID along with the ID, right? We can talk more about this a little bit later. So we talked about the task, we talked about meta, and the post. Post, as the name suggests, this is a operation that needs to be run once the task is executed successfully. In other words, in this particular case, once the service is applied to Kubernetes cluster, then these particular things are run. Okay, so the post here that we see again is again a Go template, right? However, in this Go template, we don't expect any template to be formed. Rather, we are running some of the Go template functions, right? We will talk about it maybe a little bit later, or once we try to do a proper code coverage. But this is a task, right? This is essentially a task. Okay, so to define a CAS engine, we need to have the CAS template, which has the templating that we saw currently. We need to have some values. These values, will be filled up by runtime values. It will be filled up by the default config from the CAS template. It can also be filled up from the config elements that is provided in the storage class, right? Those all things will be merged together, and a final template values will be arrived at. Okay. If you see, and then we also talked about CAS common, which is a kind of a common structure that has common operations. And these are some of the common operations. It will do some preparations for tasks before getting executed. That means it will fetch them and it will add it to its list, right? And prepare an output task. It's all about the output element that we talked about in the CAS template, the last property, if you remember. And there are some other, initializations done, which is also a common operations. This is regarding the template values. The template values is a map of string of interface. And in Go templating, if we provide values, it has to be in the form of map of string of interface. All right. So that is a prerequisite. And within that, we try to initialize something called as a task result. We initialize it to be nil, but during the run of the task, when the task get executed, these things will be populated with specific values, again as specified in the template itself. I'm trying to go a little fast, and just stop me if you feel it to be inconvenient, or if you want me to explain deep. And again, there is a run operation, which is again a common operation. If you see, it does some specific things, and it tries to invoke the runner, which does the job of run. That means all the tasks that has been specified in the CAS template will be run now. and it accepts the values. By this time, the values would have been populated with whatever it needs to be. Now we see there is a specific structure done for create, which means this is for create volume only. It has got its own. So what it does is, so here comes the embedding property. The create embeds the CAS common structure that we talked about earlier. It means the CAS create will have all the operations that the common CAS exposes. All right. Along with that, it will have its own specific operations. And there are some few more config elements which we talked about earlier, which is very specific to create only and not for delete, get, and list. That's the reason why it is finding its place here. And this is the function we saw in the last Go file. This implies this is a function which creates a CAS engine, which is only meant for volume creation. We'll not go deep into that. Um, yeah, so the CAS create has its unique operations, like we said, right? One of these unique things is it has to prepare a final config, which is nothing but merge the config from PVC and the storage class and the default config. The PVC is the one which will which has a highest priority, then the storage class config, and at the last is the default config that is exposed from the CAS template. This particular method does that. And again, these are some of the stuff that is very particular to CAS create. It adds the config to the template values. If you see, if you go down, so at the end of the method, if you see the template values, we are populating the configs. So it's in this hierarchy. It has got the final config. All the prioritized ones are there. The non-prioritized ones are removed. The unique ones will be there. So it follows a proper merge strategy. And finally, it has got the create operation, which is invoked from that last file we saw. And after preparing the config, it will call a run. This run again is the one which is defined in the common engine. Okay. So we saw the engine definition for volume creation. This is the engine definition which holds good for all these operations, that is a read, list, delete. All right. And this composes the common thing, and there is nothing else here. That means it's just a wrapper over common, and it's able to do the job. And this is where we instantiate the the CAS engine, which can do all these three jobs: read, list, and delete. So once it is done, you can see there is a read operation, delete operation, and list operation, which is nothing but a call to the run operation. All these things runs fine. Now, for those who have questions like how is a read same as delete, and how is a delete how can it be same as list? Now the magic lies in the way the CAS template tasks are defined. And then the bigger piece or the magic lies in the way the run tasks themselves are defined in forms of templates. Okay, so I'll stop a bit here. Any questions here, or should we go? Yeah.
Hi, Amit. Ganesh here.
Hi, Ganesh. Yep, tell me.
So I've gone through your PR and I came across something like no operation. You're piping something in no operation. What is the use case for that?
Okay, so that's a little bit deep into the Go templating functions. So the NOOP, that's the operation name, right? And that is a Go template function. That function will swallow any inputs that is given to it. Okay, and which means it will take in whatever inputs you provide, but it will not give out any output. It will give a blank output, blank string. That is done to preserve the indentation of the YAML files, right? If you do not do that, then the YAML file may not be indented properly, and that is the reason for having a no op template function. Maybe I'll talk about it a little bit later, because that is a deep into that templating.
Oh, okay. Thank you.
Yeah. Okay.
And one more thing, can you show this run function, how it is implemented?
Yeah. All right. So we will go to the run function now. And does anybody remember which structure has that run function? All right. So we were, in the CMD part first, which is about the handlers of HTTP request. Then we went to the volume package. And then we, inside the volume package, we talked about creation of template engines, various way to create template engine. Now we are getting to the task part. And in the task, the first thing is runner, which is the one which will actually start, try to run the tasks. Okay. So let's immediately go to the run part. And if you see here, this is also a run, that is also a run, but it calls a group runners run. Okay, right. So this is the group runner run call. I'll switch it off. Okay. So here we are. So this is the point, or this is the method which gets invoked. What does it do, right? So it will run all the tasks, right? If there is any error, it will roll back. If there is no error, it will run the output. And after that, it will return. It returns output. What is output? Output is the output again. It's shown as a array of byte, but it actually translates into a YAML format, a JSON format, YAML or JSON, whatever is needed. It will translate into that. Okay. So if it is a list, it will translate into a list of volume, a list of CAS volumes, right? If it is a create, it will translate into a create volume structure, right? And if it is a get, it will also translate to the volume structure with all the volume properties in it. Okay. We'll have a look at it maybe when we see the run tasks. So this is basically the thing that it does. It doesn't do anything like extraordinary here. If you see the run task, again, that is, you don't see any logic here. It's like it iterates through all the tasks, and it runs one task at a time. If there is any error, it just immediately exits the loop, and the rollback happens, and all those stuff happens, right? Let us see what happens in a run a task. In the run a task, this is one instantiation that happens. This is defined in a other place. We will go there. But basically what it does is it takes in the entire run task. And for those who remember it, the run task will have the meta, the post, and the task. All those three elements inside the run task, right? It will, so a executor will be created per run task, and it will get executed. If you see, this is the execute method that is being called. There are some housekeeping stuff, like if the task is unique and all, that is very typical to the runner. If the group runner expects that all the tasks that is being fed into, right, into the group should be unique with respect to their IDs. If at all there is any duplicate IDs, it will fail. It will give out the error. It's because the IDs are required to store the results, if at all the results need to be stored, right? And if the IDs are duplicate, then obviously the results will be like confusing, and all those stuff of issues will happen. That's the reason why the group runner tries. The group runner ensures that all the tasks should be unique. Uniqueness is taken out from that ID element, ID property, and this is again defined in the run task itself. Okay. All right, so the task executor will take a task and it will do some housekeeping stuff, and before it executes, after it executes, again, it does a little bit of housekeeping stuff. You're not bothered about these things. It executes, and after execution, this is the one which what it does. It plans for a rollback, right? So once a task is executed, even though it's executed successfully, it will plan for a rollback, right? It will store some of the elements that will be required in case this task is required to roll back in case of a future issue in some other task. Okay. Are the things clear? This is just a planning for rollback and not the actual rollback. Okay. And then there is nothing else here. If you see, all the other things are like, yeah.
So,
So
Amit,
yeah.
lost a little bit here.
Okay.
Let's say like run task has 7 tasks that we have to execute, right?
Right. Yeah.
And if the 5th task is where we hit a error,
Right. Yeah. Yeah.
does it? How does it roll back all
Yeah.
the way till the first task?
Yeah. Right. So, so what happens here is, this is the the method which actually handles that. When a task is run, let's say task 1 is run, it will be run successfully, and it will be its results will be planned for a rollback. In other words, some of the values or properties of those things will be pulled up in an array here. It's known as rollbacks array. And in a scenario where the actual error happens, we'll see a scenario where the error happens. For example, this got executed, error is not nil, it will return, right? And what we saw is, in the plan for rollback, it keeps on adding the rollback elements to an array, right? So in case there are 7 tasks and the 5th one resulted in an error, all the earlier 4 tasks should have been added to that rollbacks, that particular array. And now in the 7th execution, we've met with an error. It will return here. We'll go back to that return stuff. Here again, it returns here. We'll go back, and it is here, and we call here. We call the rollback. This is the actual rollbacking.
Okay. And how do we know how, for example, like in the configuration, can the admin specify for this task what are the rollback steps?
Okay, so rollback currently is like a very naive. It's a very simple implementation. It doesn't require admin to specify anything. What it in fact does is, its logic is, it will see if the original task is a put operation, then the rollback will do a delete. It will set it will create a task of its own and set that task as a delete, and the kind as whatever the task kind was. If it is a service, it will mention the kind as service. These kind of things it will form while adding to the rollbacks array.
Cool. And follow-up question. So this, let's say like 5th step, something failed, and the logic is actually rolling back everything. How how will the status be for the API? For example, like the whole thing started with maybe like my MAPI server create volume up, right?
Yes. Yes.
And we went through half of it, and then we started rolling back.
True.
What error will be returned to that API?
Yeah. So if you see this, it will be the original error that will be returned to the API. The rollback errors, there may be also error in the rollback, right? So I remember the rollback errors are just logged in as warnings. So it will be the original error,
Okay.
which will be, this is the warning only. It is printing. If at all there is any error during rollback, it will not send out that error. It will just log it as a warning. The original error will come out.
Okay, Amit, thanks.
Okay. Okay, so by virtue of this question that Kiran asked, I actually explained what the rollback is all about. It is a very simple thing currently, and I did not find any need to have it complex. We will see if it needs to be really that complicated, or try to manage those complications of rolling back. It may become that in the future. Currently, it's just that. For example, let's say if there was a task which required only a get operation, right? Get PVC and get me some labels in the PVC, right? There is no need for a rollback. And if we do a rollback of the PVC, then what do I need to do, right? So it doesn't do a rollback of those kind of tasks. Only the tasks where the group runner did a put operation, that is apply operation, then only it will roll back that task. Otherwise, other tasks will be like, it will not be considered for a rollback. Okay, so this file has these things only. It's a runner file. It's a group runner. It has got an array of tasks. It has got an array of rollbacks, and the rollbacks are populated dynamically during the run. Running the set of tasks. The tasks are populated in the in that previous during the CAS engine and all those stuff. It is just populated, and that is it. It does a for loop and executes. What we will do now is we will get into the task executor, which is like executing one task. It is all about it is a 1:1 mapping with the task. Okay. Task info. So this is the file which has that, and this is a big one. This is a big file. So and this is a file which has actually got a lot of intelligence. Again, we see that there is some kind of interface which executes a method, and these entire CAS engine tries to have single method interfaces due to so many reasons. It's a pattern. It's a good thing to have, and all those things. That is also an output executor. This is an execute, and this is an output. It has tried to differentiate between executing a task and outputting a task. Yeah. So there is a reason for that. That's the reason why it has got two methods exposed via two different interfaces, and we have already seen this, right? And yeah.
Is Priya? Uh,
Yeah. Okay. So we already talked about the run task, right? And in the future, we are going to convert, translate, or we will be converting the run task to a Kubernetes custom resource, and that's the reason why we have written this to-do statements and all. And again, I'm repeating, we have a meta, task, and post. These are the three things that is present essentially in a task, any task. Okay, and it's not mandatory to have all the three present at the same time. We will, if one tries to look at various tasks that are defined, that are required, we need not have all the three at the same time in one task. Okay, it's not mandatory. All right, we will come to the task executor. And one more thing that I would like to say is, like I talked about the interfaces, right? It's all a single method interfaces. It exposes one contract only. And then if anyone remembers my previous talk about defining structures for data and defining structures for behavior, you can find that here. This is a structure which is defining the data. The run task is a data structure for data, pure data. And this one is an executor, which is for executing it, which is the behavioral elements will be all defined in this structure. All right. And if you see, this behavioral structure also composes a run task. It is good, and it helps us in the future if we actually differentiate, segregate these responsibilities. Okay. There are other elements of this executor, like template values. This is the same values that I was talking of. In Go template, there are two aspects. One is the templating, one is the values, and this is the values. And definitely it requires this data type map of string of interface. All right. So again, in this structure, the other thing of importance is meta task executor. So it delegates. The task executor composes the meta task executor. In other words, whenever there is some operations with respect to the meta part, right, with respect to this part, then the task executor will delegate that to this thing. Okay, just 1 second. 1 second, I'm just cutting off. Okay. All right. So this is done. All right. So in this case, there are some other methods like creating. I'm getting a call. Just mute for some time. Just sorry for that inconvenience. Okay, so there are some other methods, functions defined here, which is like getting a Kubernetes client, structure defined based on a namespace. And there is something called resetting the client based on on the namespace. So during the list operations, we had a requirement where we need to run the list operation across multiple namespaces. Okay, and this is the case where the list operation had to depend on something called repeat you. So it had to repeat the same task, multiple times. The times were dependent on the number of namespaces that were configured. For example, there are two namespaces. One is default, another one is OpenEBS, and we have CAS volumes in default as well as OpenEBS. So what we do is we define a task, right, with some properties, and we say that you have to repeat yourself first based on the namespace called default, and then based on a namespace called OpenEBS. I'll try to explain that more in details, how we do that. So basically, again, this is like it. This is the method that gets called in the runner, right? And it exposes a few of the things. And if you see the output, why it is different from execute is because the output job is just to marshal the Go template with by filling up the placeholders with appropriate values and resulting into the template which is filled up with values. Its job is that it doesn't depend on executing a Kubernetes client API. All right. So I thought it will be better to have a different method exposed and all those things, and that's how it has been designed in this way. Okay, we can see a output task where we can actually get to know, like it doesn't have any meta element in it. We can actually see that now. Action colon space output. All right, so you see a output task, right? This is an output task whose action is like output. This is how a task is determined, if it is output versus if it is a get versus if it is a list and so on, if it's a patch or so on. And okay, so I was saying there is no need for a meta, but there is a need for a meta. I'm sorry, I'm just getting so many calls. 1 second. Sorry, I'm getting this so many calls. Just keep it on silent. Okay, so like I said, the output has some elements of meta in it, right? The meta describes that is the task of output type, and the actual task, if you see, it is defined as a CAS volume, which is an internal type with some configurable elements like Go templating elements there. What we want is when this task is invoked, we just want this output in filled up with appropriate values, and that is it, right? So this all can be possible by just templating it, by running Go template on it. Okay, because the values will already been filled up by other tasks. It doesn't really need to go through the Kubernetes APIs once again. This has been the case most of the times, right? And that is the reason why you see the output just invokes a Go templating stuff, right, and nothing else. Okay. There are other elements like not found error, and there is something called verify error. So during templating, there will be cases where one tries to get a volume, but the volume doesn't exist, right? So those have been handled in this kind of runtime errors. We will write some functions, some template functions, and which, if executes to true, or if it results into a false, will throw up a not found error. And while executing the task in this code, it will look out for those errors. If it's a not found error, it will exit the execution. And finally, in the HTTP handlers, it will be checked. If it's a not found error, then throw a 404 error instead of a 500 error, right? So so those kind of stuff has been handled out, and that can be handled out. That has been handled in the templating itself. The templating has a intelligence to throw out a not found error versus a runtime error, or versus some other kind of errors, which is like another kind of error is like verification error. In a task, a task can be, we talked about repeating a task, right, some time back. Repeat a task based on the namespace. There is another concept in task which we call as verification. Uh, for example, if we expect a replica deployment to have 3 pods, right, 3 replicas, and while this template is getting executed, there are only 2 replicas. The other one has not is still not running, or it's not deployed at all. So what we can do is we can actually configure or define the task functions in a way which tries to find out the count of the pods, right, the count of the replica pods that are in running state. And if that count doesn't match the expected count, then throw a verification error, right? And the template has a logic to understand a verification error and do a retry, right? So this is a retry is the other concept that I'm talking of now. This is different from repeat. All right. We will try to see where these things happens. Okay. So I was talking about repeat, right? So this is a function which handles that. It handles the repetition. It understands if the task needs to be repeated or doesn't need to be repeated, right? So it will accordingly execute it, right? And repeat and verifications are different, right? Repeat and retry are different. That is also handled out here, if you see, right? So this retry and verification error, like I said, if you want to retry something, if you want to retry a task given some temporary errors, like the number of replicas has not reached the expected thing, then we can actually throw a verification error and we can do a retry on it, right? So retry, as the name suggests, it has some amount of attempts and it has some intervals between the attempts. This logic does that. So in the specific retry attempts, it tries to execute the task, and here, after executing a task, it tries to see if there is any verify error. If at all there is a verify error, it will log a warning that a verify error was found, and it will do a retry operation. It will retry that operation after some sleep intervals. Okay. And if all the attempts have got exhausted, then it will return with the error, with the last error. Okay, with the last verification error. Okay, so execute is the function, or is a method that we saw being called from the runner, right? Was it execute it, or let me check it if it was execute or something else. Yeah, so in the run a task, we saw this is a method that was being called, right? Execute in turn calls repeat with. In the repeat, it checks if it is a repeat or not repeat, and it will invoke the necessary methods. So the necessary one is like a retry method. Within the retry, it will do a actual execution. This is how the things has been handled here. Um, and we will go to this execute it. This is where the actual execution happens. Okay, so in the actual execution, this is a method where the actual task is getting executed. It checks out the kind of a task, right? It checks if it is a deployment, if it is a put deployment or patch a deployment, or if it is a delete a deployment, delete which version of deployment, delete apps v1 apps slash v1 v1 deployment, or if it is a delete of extensions v1 v1 deployment. Those all things, or if it is a list operation. So depending on that, appropriate method invocation is done here, right? Once the task get executed, the post executions happen. This is the place where the post property of the task gets executed, right? This is the one, the post property, it gets executed. Okay, and since the post property is also pure Go templating, it's just a templating call which is done, right? The not found errors and all are actually handled, or actually try to be found after the post execution. Okay, so this is where the not found error is checked. If it is a not found or something, it will give appropriate error. Otherwise, it will just go on as is. Okay. I'm trying to go okay, so the other methods that you see here are relevant to the specific task, whether it is a put core service, or if it is a delete core service. All those things are specific to the task, right? Okay, so yeah.
Quick one. This you mentioned that this might have some iteration logic, right?
Yes, yes.
Can you show where that is?
Okay, so there are like two iteration logic involved. That has been differentiated by repeat logic, and there is one retry logic. Okay, so I had to so the repeat logic is where we are talking of iteration. Okay, now what it does is in the list operation, I'll tell the example, the scenario where I had to use a repeat. During the list operations, list of CAS volumes, we are expected to do a list operation on multiple namespaces, right? So what it does is, what we can do is, in a task, we can define a task with repeat with property. Okay, in the repeat with property, we can say that it needs to be repeated based on n1 namespace, n2 namespace, n3 namespace, or so on. Okay, and it will do that repetition. Okay, and repeat means it will repeat that entire task just by switching the namespace. Okay, in this case, it had to switch by namespace. In some other case, it may have to switch by based on whatever it is. But most of the cases, switch will not be switching will not be required. In this particular case, it was required because Kubernetes APIs had to be reset based on the namespaces. But on the overall, if you see, it will repeat based on the resources that has been assigned to the repeat property. Let me just show up that example. Okay. So what we are seeing here, we are seeing a config map, which is a run task. We have given a name. It lists some controller services. And we see something called repeat with. Okay. So repeat with, we see that there are two properties. One is kind, one is resources. In this particular case, kind was like required, but I assume, I feel that in most of the cases, the kind element may not be required. Let's concentrate on resources. This is the place which is again an array of strings. In this case, all the namespaces will be set. Okay, and how will these namespaces be got? These namespaces will be either be given to the API server via those HTTP requests via headers or some other forms. All right, but the objective here, but what we need to know is we need to know the resources based on which this repetition should happen. That is the entire motive of this definition of this repeat with. And with each repetition, if you see, with each repetition, we are trying to get some outputs, right? Those outputs are again defined in the post operation. We have configured in such a way that the output will not be overlapped. It will be either appended or it will be indexed based on some uniqueness. Here the uniqueness is namespace slash the PV name. So we are indexing with that, and we are appending or setting the values, whatever values we need. In this particular case, we are interested with cluster IP, so we are doing necessary indexing and uniqueness we are setting up so that the cluster IPs can be preserved. Why it is preserved? Because when we actually render that list, we need that cluster IPs to be set against in a particular way. Okay, so Kiran, I expect a lot of questions here. Maybe you can actually start off with questions. I'll try to explain if I have.
Still processing.
Yeah.
I'll probably comment on the PR and then we'll take it.
Yeah.
Also,
okay.
in terms of time check, right? I think we are 20 minutes past the time.
Yeah.
Maybe like we can have another session.
Yes.
On this one.
Yeah. Yes. All right. So this one has actually covered almost entire things except the template functions that we have defined. There are a couple of 5 to 7 template functions that we have defined, and we are using it now. Earlier we did not have we were using the template functions that were provided by the Go standard library and by the Sprig templating library. With this PR, we have introduced good number of, let's say, 5 or 7 7 or 8 template functions, and we are making use of it heavily. One such was NoOp, N-O-O-P, that Ganesh had asked earlier. Maybe we can actually end the session now, in the sense, like, if you have any questions, I'll try to answer. And maybe we can have a repeat session that starts with the task and template functions. So if there are any questions or any things you can ask now, I'll try to answer them now, or maybe in the next repeat session, I'll try to answer them, clarify them.
So I'm good for now, Amit.
Okay.
Thanks for the session.
Yeah. Probably I'll request, like, if some of you can go through the PR, maybe you will have some definitely more questions. There are 2 PRs actually. One is the PR in the community, which is the PR number 12. This is the PR pull request 12. This says how to use the CAS template, and then the other PR is actually the code. This is PR number 376 in OpenEBS Maya repository. So have a look at both these PRs and probably come up with the questions or come up with the review comments. I'll try to answer them, or if required, I'll try to rework on the PRs. All right. So thanks everyone for attending this session on CAS template. So we can end the session now. We will wait for the next one.